Alright, so the next subtopic is the laws of logarithms. If you look at the screen, there are three main laws. The first one is LGA plus LGB, giving LGA multiplied by B. So that's the first rule. And then the second one would be log A minus log B, giving log A divided by B. So when there is an addition symbol, you should multiply those two values. And when it's negative, you're supposed to divide them. And note that the base for these two logarithms is the same. Over here it would be 10. And then the last rule is NLGA, giving LGA to the power of n. So let us work on some examples. So the first one would be LGA plus LG2. So we using the addition rule, so it would be LGA times 2 because there's this symbol in between, meaning we're supposed to multiply this and this. That gives LG16. Okay, over here we can write T as LG T to the power of T. 10 to the power of T. So this would be LG 10 to the power of T plus LGW. This would give LG 10 to the power of T multiplied by W. Okay, let's look at the third one. So we can write 2LG3 as LG3 squared. That would give 9. And similarly, 3LG2 would give, this is the third row, that would give us LG8. So LG9 plus LG8 would be LG9 into 8. And 9 into 8 is 72. Alright, let's work on the next examples. Okay, so here the base would be 10. So log base 10, log 10 base 10 would give you 1. So we can substitute this into the equation. So LG10 minus LG2 to the power of 3 plus LG20. So we can write this as, first let's work on this. So that would be LG10 divided by 8 plus LG20. Okay, so we can write this as LG5 by 4 times 20. So this would be 5 into 5, giving LG25. So that's our answer for this question. Now let's work on the next one. So in this case, we can write this as log base 5, 3 to the power of 3. This may not make sense right now, but just hold on. So that's the first one. This we can write log 9 base 5 as log 5, 3 squared. So now if we substitute these two, we can write it as this. But then according to the third rule, this one, we can write this as 3 times log 3 base 5 divided by 2 into log 3 base 5. We can cancel these two out because they're literally the same thing, which leaves us with 3 divided by 2. So that's our solution. Now let's do this lengthy problem. Okay, so we'll work on it step by step. Let's take this first. So this would be log base 2 to the power of 5 to the base 6 Right now we'll just leave it as that, and then the next one would be log 3 squared base 6 minus log 16 to the power of 1 by 2 base 6. This is essentially 4 minus log 12 base 6. Okay, now let's try to simplify this. Using the first rule, we derive this, and then we can take the negative symbol common and write log base 6 4 into 12. Okay, let's just find the answer. 2 to the power of 5 is 32, multiplied by 9, which gives us 288, minus 4 into 12 gives us 48. So we can write this as we can write this, and then if we find the answer, that's essentially 1. You can like plug this into your calculator to see whether it's true or not. Alright, so the next subtopic is natural logarithms. So given the exponential function f of x equals e to the power of x, the inverse function would be f inverse of x equals log x base e. So this is very self-explanatory. I don't think I'll have to really explain this because we've already done this in terms of 10 and a. But instead of base 10 or base a, we're writing it in base e, where e is like a constant, just like pi. So ln x is used to represent log x base e, and we often call it the natural log of x. And all of the laws that we have learned before will apply to the natural logarithm too. So we won't be doing any problems solely based on this, but let's just look at everything combined, all the problems. Okay, so let's just start. Okay, let's start with this question. 3 to the power of x minus 1 equals to 200. So let's apply log base 3 to both sides. Okay, so we know that this would equate to x minus 1, giving log 200 base 3. So when we make x the subject of the equation, this is what we'd get. And then if we want to write the value of this, it would be 5.82 to 3 significant figures. Okay, now let's look at the next example. So we could do the same here, except apply log base 7. So log 7 to the power of x plus 3 base 7 equals to log 1000 base 7. So that leaves us with 2x plus 3 equals to log 1000 base 7. On rearranging, we get this value. Okay, so the value of x would be 0.275 to 3 decimal places. Now let's solve the last equation. So e to the power of x equals 1000. We just learned this. We have to apply the natural log to both sides. So ln e to the power of x, giving ln 1000. So x equals ln 1000, which is essentially 6.91 to 3 significant figures. So that's our answer. Yeah. And now let's look at this. This is also very similar. So we have to apply the natural log to both sides. So let's just work that out. And that would give us 2.85 to 3 significant figures. Now let's look at this. We can write this as log 3x plus 3 to the power of x plus 1 whole squared base 3 equals to log 480 base 3. We can write this as 2 log 3 to the power of x plus 1 base 3, giving this. So therefore x plus 1 equals log 480 base 3 by 2. On rearranging, we get x equals to log 480 base 3 divided by 2 minus 1. And this would be 1.81 to 3 significant figures. So that's our answer. Now let's work on this. This is also very, very similar. So actually we'll first divide both sides by 2. And now it's very simple. You can directly write this. Okay, so this would be negative 1.90 to 3 significant figures. Alright, that was easy. Now we have to find the intersection points of these two equations. Okay, so let's equate them first. So this is essentially what we get. So if we rewrite this, this is what we get. And the value of x would be ln 6. That is 1.79 to 3 significant figures. And y would be, which is 6, I think. Yeah, it's 6. So the intersection point would be 1.79, 6. So that's our final answer.